Hey mathematicians, here are your notes for 13.4 Area and Law of Sines Day 1. So we're going to start by considering that triangle. You'll notice it's labeled A, B, C, C, and H. So if we want to find the area of it, what is the formula? Well, we know the area of a triangle is always 1/2 base times height. Now we have the H being height, but in this case our base is C. So our formula for this specific triangle is going to be 1/2 C times H. However, we obviously don't always know the height of a triangle. So if you wanted to express the area only using the actual side lengths, so A, B, and C, and then the angles, not H, what formula can we generate? And of course, because we're in the trigonometric unit, we're going to be using trigonometry. So the first thing that I notice is I'm going to use side or angle B here to talk about H. And remember, I know the side length, so I can use A, B, or C in this process. If I use angle B, I can write a trigonometric function that says sine of angle B is equal to opposite H, just talking about this little triangle here, divided by hypotenuse, which in this case is A. So that looks a little backwards, but that is how our triangle is labeled. Now, if I can't use H, what I can do is solve this formula for H. I'm going to multiply both sides by A, and I'm going to get H equals A times the sine of B. So that is what H is equal to. Now I can go ahead and rewrite that formula from the first prompt as area equals 1/2, remember it was C times H, but since we're going to replace H, we're going to write it as C times A times sine of B. And that's a lot of letters, so if you want to put the multiplication in between there, you can. But that will be our formula for the triangle above. So we can actually generate 3 formulas using the exact same method. So the area of a triangle is 1/2 the product of the lengths of the two sides and the sine of, in this case, the included angle, and this is very important. So notice from up above, C and A, should show you here, C and A are these side lengths. Our included angle means the one that is in between those two sides, the angle that's created with A and C. So our area formulas are going to be this: 1/2 B times C times sine of the included angle, which will be A, 1/2 A times C times the sine of the included angle, which in that case would be B. And then finally, we have BC, AC, now we need the AB. So 1/2 AB sine of the included angle, here's A, here's B, my included angle is C. So those are my area formulas. Now, you don't have to memorize all of these, you can memorize one, and as long as you know that it's 2 side lengths and the included angle, that's the biggest thing. So example 1, find the area of ABC to the nearest tenth if A is 31 degrees, B is 18 meters, and C is 22 meters. I'm a visual person, so I'm going to go ahead and draw this triangle. Remember that your angles are uppercase, your sides are lowercase, and they are always across from each other. So the angle A is going to have side A directly opposite. B and C, and that's a lowercase. All right, so A is 31 degrees. B is 18 meters. I'm going to put equal to 18, and C is 22. So 2 sides and their included angle. Remember, area is equal to 1/2 B times C times sine of A. That's one of our formulas up here using the 2 side lengths that we have. From there, we're just going to plug numbers in. 1/2, B is 18, C is 22, and A is 31.
Mr. Sponsler, please stop by the library or call extension 1207.
The joys of working in a school. Thanks for that announcement. All right, so I'm going to go ahead and throw that in my calculator. 1/2 times 18 times 22 times sine of 31. Notice I am in degrees, I'm not in radians, so double check that. And I get 101.9 with a bunch of other stuff. So I'm going to say that my area is approximately 102 meters squared. All right, let's see what else we can do with sine. So remember the law of sines for geometry. I like this one a lot just because it looks nice, and that's kind of a shallow thing to like a math formula for, but yeah, it just looks very balanced to me. So sine of A divided by the side A is equal to the sine of B divided by the side B, and sine of C divided by side C. So given any two, we can find, given any three, we can find a fourth, and it doesn't matter which pieces we have. Obviously, this last side is A. So when can we use this law? Well, you should remember from geometry that our nice cases are when we have two angles and one side. And those are going to be our ASA cases and our AAS cases. And basically what we do to solve these is we find the third angle, that's the easy bit, and then use law of sines. And use, I'm going to shorthand LOS, use law of sines. The other case that was talked about but was never really covered to the depth that we're going to cover it in is two sides and an angle. And remember, this was the bad one because that is SSA. Obviously, we don't spell it the other way in class. We only spell it this way. We will work on this a little bit more tomorrow, but we have to know an angle and its opposite side to use the law of sines. So go ahead and put that little note. We must know an angle and its opposite side to use law of sines. For right now, let's go ahead and look at that first case. So solve the triangles below. We've got ABC here with a 45 and a 55. Let's go ahead. Remember, solving the triangle means to find all sides and angles, all of them. So if it isn't given to you, you need to find it. So with triangles being 180 degrees, let's go ahead, subtract 45, subtract 55. We get that that final angle is 80 degrees. From there, we can just use law of sines. I'm going to go ahead and use this pair right here because I know opposite side, opposite angle. I'm going to set it up as sine of 55 divided by its side length is equal, and then I'm going to set it up with an unknown. So sine of 45 divided by that unknown A value. And then from here, we're just going to cross multiply. So sine of 45 times 12 divided by sine of 55 equals approximately 10.4. I'm going to put that up here, 10.4. And then we'll set up a similar one with sine of 55 divided by 12, set it equal to sine of 80 divided by B. Same thing, sine of 80 times 12 divided by sine of 55. You get approximately 14.4. So I just double checked, do I have all three sides solved? Yes. Do I have all three angles? Yes. So I am good to go on this one. Go ahead and pause the video and then try the next one on your own. All right, hopefully you paused the video, tried that one on your own. Let's go through it together. This one is a little different because we don't start out with two angles. We actually start out with two sides and an angle. But I can solve the same way I did before. I've still got this known pair, and I'm going to use that to start. So sine of 75 divided by the matching side length there is equal to sine of A divided by 2. And obviously we don't know what that is, so we're gonna cross multiply. 2 times sine of 75, close parenthesis, divided by 3. But remember, this isn't my answer. This is what sine of A is equal to. So if you need another step to see what I'm talking about, sine of A is equal to approximately ... I go ahead and save a step by just doing second sine, second answer, and it's just this button right here. That'll put whatever decimal I had in. No need to even round. The calculator will do it for me on that. There is my angle measure. I'm going to round to 1 decimal here. So A, we're going to say, is approximately 40.1 degrees. All right. Having that second angle, we can go ahead and say 180 minus 75 minus 40.1. We get 64.9 for B. And now we can go ahead and find that third side length. So set up the same one you did before. Sine of 75 divided by 3 is equal to sine. I want to find side B, so I use angle B, 64.9, and cross multiply. And we get that side length to be about 2.8. All right, check yourself. I have 3 side lengths and 3 angle measures, so I have successfully solved this triangle using law of sines. All right, that's the basics. Tomorrow we take a little bit closer look at case 2, where you have 2 sides and an angle. If you have questions before then, don't hesitate to let me know.